2, 1.
Good morning or afternoon, maybe even evening, depending on where you are and when you're watching. Okay, this will be day, I think it's day 16 of probability. And today we're going to be blending probability questions with some counting methods. Okay, and that's what we're going to look at today. So let me just double check to make sure it's the right day here. And then we'll get the Blackboard open here and we'll get going pretty quick here. Okay, so. Wait for the Blackboard here. Okay, so come on, load up here. Okay, so according to today, yes, today would be day 16, not 15. And this will be part 1. We're going to break this one into 2 parts today. Okay, so there we go. Let's get this set up here properly. Okay, so what are we going to look at today? Let's first get this. Okay. All right, so this is day 16 of probability. And we're going to be looking at basically we're going to break this into 2 parts. Okay, and we're going to be looking at problems of finding probability or odds, I guess, using the various counting methods. From chapter 4. Okay, so what we're going to be looking at today here, and let me just pop open my notes here. We'll probably be looking specifically at a few different kinds of examples. I don't think I'm going to, sometimes I do this all in one shot, but I think I'm going to break it into 2 smaller shots and then give the practice in the second day here. Okay, so what we're going to look at, today, or over the next 2 days here, we'll look at probability with permutations, combinations, okay, probability with combinations, repeated permutation, counting principle, or the basic counting principle, and finally, with the help of diagrams. And like I said, we'll do some examples of each type of these permutations. Permutations, no, permutations. Okay, so that's what we're going to look at today. Now, the first place I'm going to start with is if we go back into section 5.2, and we were looking at odds, and there's a percentage example, number 8 on page 310, that I've been asked about a few times. And that's mainly because maybe I didn't do an example of odds with percent. So let's take a look at that one to start today out as an example of a percent odds question. So this would be, if I go to my marker here, where we're going to start today. So this would be like number 8 on page 310. And this question is a good example of percent values and odds. Okay, so the first thing you have to remember when you're thinking about percent, that percent always comes out of a total sample of 100. So that's your total sample. And that fact or that little tidbit there will basically be all you need to know to actually work this out. So let's read the question first. It says about 8% of men and 0.5% of women see no difference between colors red and green. These people are often useful in the military because they can detect khaki camouflage much better than people who do see the difference between red and green. What is the odds in favor of Alan being able to detect the camouflage? Now, the first thing you have to assume here is that Alan's a guy. There's no guarantee on that, but that's what we're going to assume because we'll say that's a male name, but you never know, right? So that's the first assumption we have to make. So we're going to say, okay, if Alan is a guy, okay, that means there's 8%. It says 8%, about 8% of the men see no difference. So see, and then we want to see, this is the color blindness, we'll call it. Okay, so if we're thinking about 8%, if we break that down into outcomes, the probability would be 8 over 100. Okay, this would be the total in the sample size because a percent is out of 100, and this would be the number of successful. Favorable is what we were calling them yesterday. Meaning favorable outcomes, meaning that he's colorblind. Okay, so if we think of that, if we want to do odds, we have to have the unfavorable. So to get unfavorable, we simply take the total minus the favorable. So this unfavorable would be 100 minus 92. Oh, sorry, minus 8. Pardon me, guys, which is 92. Okay, so now you have your favorable outcomes, your unfavorable outcomes, and then your total outcomes. So now that we know the favorable and unfavorable outcomes based on percentage, we can then calculate the odds for being colorblind. Okay, so odds for being colorblind, that's going to be favorable to unfavorable. So the favorable one was 8 over, or 8 to 92, which we can reduce. We can reduce this. If we reduce that by dividing each by 4, because 4 goes into 8 and 4 goes into 92. So if you divide 4 into 8, you get 2. If you divide 4 into 92, you get 20. What do we get here? 12, 23. There we go. So our odds in favor of Alan, who we're assuming is a guy, of detecting camouflage would be 2 to 23. Now, I don't know if the book does the girl one, but let's assume that in case Alan's a girl. Okay, if Alan was a girl, woman, not woman. Woman, there we go. If Alan was a woman, he would or she would have 0.5%. So we got to take that and look at it as 0.5 out of 100. So if we wanted this to be not decimals, whole numbers, we'd multiply it by 2. So it'd be 1 out of 200. Okay, so this is the favorable. And the unfavorable. Let's just use our abbreviations there. Okay, so 1 out of 200. So if we take the total being 200, so 200 minus the favorable, that's going to give us 199 unfavorable. Okay, so now that we know we've got one favorable and one unfavorable, the odds for Alan being able to detect camouflage if Alan was a woman, we would say in this case 1 to 199 odds in favor of detecting camouflage given Alan's a woman. So we can probably assume that Alan's a man based on name, but you can't be 100% sure. So either of these would be okay answers by me. 2 to 23 for if Alan is a man, and 1 to 199 if Alan is a woman. Okay, and that makes sense because 0.5% is considerably lower than 8%. Okay. All right, so that was question number 8 on 310, and I didn't do any percentage examples yesterday, so I thought that would be a good way to start out our class today. And I'm also going to, like I said, I was going to break this into 2 pieces today. So I'm going to look at a couple of the questions that show up regarding the probability counting methods. Now, if you look in your book in section 5.3, there are at least, they give you, what does it give you? About 4 different examples. They give you a permutation example. They give you a counting principle and permutation example. And they also give you a combination example as well. So I'm going to do some of those as well, different type of examples, to give you an idea how you work probability or odds out using the counting method. So let's do that on the second page. Okay, so the first one I'm going to look at with you today, first of all, is I'm going to look at one that's not in the book right now. I'm going to look at a common one that's used, the two-sided die problem, okay, and how that works, okay. So that's our first example today. And they have some in the problem questions, but they don't really show an example of it till later on in the unit. So I'm going to start early on that. So we're going to do a 2 dice type, we'll do 2 6-sided die. That's a common one. 2 6-sided dice problem. Okay, so now when we get into the next section, which is 5.4, I believe, let me just double check here. Oh, mid-chapter review, which we'll probably do. And then 5.4, that's when we start using the word or a little bit, and we use the principle of mutual exclusion, which we'll talk about a little bit. And then we'll be looking at the dice problem in a different way. But right now we're going to look at a 2-sided die problem just with probability. So this is the basic type. So let's say, what is the probability of rolling a total of 8 on two six-sided die. Dice. And we'll throw in an odds question as well, because sometimes they might say odds. What is the odds against this happening? Question. Okay, now we're always talking about theoretical here. So the first thing you want to do with a six-sided die is, what is the sample space? Well, some people might say, well, it's 6. Well, no, there's two six-sided die. So some people might say, oh, that's 12. Well, no. If you go 6 by 6, because you can get 6 different rolls on a one die and 6 different rolls on the second die. So you can have actually 36 different rolls. So sometimes it helps to make a little chart here. So if I were to make a little chart, which I'll just use my line tool here for. So I'm just going to make a 6 by 6 chart for us to use. And you can always draw these out, or pre-make one for yourself and carry it around. You'll use it a few times. So 1, 2, 3, 4, 5, 6. And we'll go this way. 1, 2, 3, 4, 5, 6. Gotta go all the way down. Whoops. Got to go all the way down there. Okay, 1, 2, 3, 4, 5, and 6 out here. Okay, so this is my little grid that I'm going to have. So if I were to, and I'll use my marker here, and I'm going to use some colors here. So if I had, this is die 1, 1, 2, 3, 4, 5, and 6. What I could roll on die 1, die A we'll call it, so we don't get confused. And if this was 1, 2, 3, 4, 5, and 6, and this was die 2, or B, okay, and so we can get our totals here. So you can never get a 1 and two-sided die, because you got to get a minimum of 2. So there's 2, and then if we go into here, this would be 3, 4, 5. These are our totals, all the way down to 7. Here, the same thing, 3, 4, 5, 6, 7, and 8. Here, 4, 5, 6, 7, 8, and 9. Here, 5, 6, 7, 8, 9, and 10. Here, 6, 7, 8, 9, 10, and 11. And here, 7, 8, 9, 10, 11, and 12. So we can see in here that we have 1, 2, 3, 4, 5 favorable outcomes from 36. So our probability of rolling an 8, I guess we could just use green there. Probability of rolling an 8 is going to be 1, 2, 3, 4, 5 out of 36. Okay, or if we wrote that as a decimal percentage, number 5 out of 36, let's see what it is. 5 divided 36, 0.139. Or if we wrote it as a percentage, 13.9%. Okay, so that's how you can get the probability. Now, obviously, what are the odds against this happening? So odds against an 8. Okay, so this is unfavorable over favorable. So how many unfavorables do we have? Well, if we have 5 favorables, we have 36 minus 5 unfavorables. So we'll have 31 unfavorable rolls over 5 favorable rolls, which can't be reduced. Or if you write it like this, sometimes it's written as 33 to 5. That's odds against, or 31 to 5. So that's a typical example with a die question. Now, you might get a question that says, what is the probability of rolling something less than 6? So that would be all of these samples. Okay, and later on when we get into the next section, we'll be talking about or. What's the probability of this, rolling this or that? So you have to be careful because you got to remember they might overlap, and that's what we'll get into, but we'll wait for next section to get in that. So that's our first example today. Just an example of using odds and using a six-sided die type of a problem for ourselves. Okay, so let me just check where we are here. It's about 20 minutes, good, so I can do a couple, maybe I'll get into a couple more examples here. So let's do a second example now that uses permutations in our problem. Okay, so let's do one with permutations. So we'll do that under here. So this example that we're going to look at today is a probability that uses permutations. All right, so let's set up an example of permutations here. I've got one set up here. Let's try this one. All right, so let's say Al, Jeff, and Sam, enter a race with 8 lanes, we'll say. Okay. If each boy is equally likely to win the race, if each member of the race, if each runner, we'll say, is equally likely, not always the case, right, to win the race, find the probability for all 3 to be in the top 3 positions. Okay, so, and we're going to say medals. Okay, and it matters if you get a gold or a bronze. So each instance, if Jeff gets the gold or if Jeff gets the bronze, it's going to be different. Okay, so the first thing that we got to do, step 1, is to find out what is our total sample size for all 8 runners. Okay, so the first thing we ask ourselves in step 1, let's make this skinnier so we can write a little bit better. Is to find the total ways 3 runners can finish in the medals. Or top 3, right? Okay, with order mattering because it's a race, gold, silver, and bronze matter. Okay, so how many ways can 8 runners finish in the top 3 is the question we ask ourselves. So that would be, you could either do counting principle and go 8, 7, 6, or you could do 8, P3 because order matters. Either of them would be acceptable. So this one would be 8 factorial over n minus r factorial. Remember, it's not a combination because order does matter here. Oops, n minus r. I should write in what the numbers are. Sorry about that. Let me write that a little better. 8 factorial over n minus r factorial. So this ends up being 8 factorial over 5 factorial, which in this case is 8, 7, 6, because the 5 cancels out all the rest. So we've got 336 ways that you can have 8 runners finishing gold, silver, and bronze where it matters which type of medal you get. So that's the first step. The second step is to find the favorable outcomes. So step 2 is to find the favorable outcomes. The top, using counting methods, right? The top of the probability. Okay, how many ways can 3 boys finish first, second, and third? That's what you're going to ask us. Not the 3 runners. Okay, so how many ways can we get these 3 boys in? We're going to have to assume the favorable ways assume that they finish in the top 3. But if we were do a little tree diagram, we could say, okay, well, how many ways can they finish in 3 positions? So we assume that the favorable outcome occurs. We got the 3 boys. So that we have 3 boys and they could finish in the top 3. So we could have, what do I call these guys? Al being first, and then Jeff and Sam being second and third, or Sam and Jeff flipping it around. So there's 2 possibilities. Or we could have Jeff being first and then Al and Sam, or Sam and Al. There's 2 more possibilities. Or Sam being first, right? So this is basically a factorial question. We've got our 3 positions filled by 3 boys. So there's 3 choices of who could finish first. Once we take that away, there's only 2 choices left for who can finish second, and then 1 for third. So there's 6 ways that the 3 boys can finish first, second, and third if they're in the top 3, right? So there's 6 possible ways. So the last step then is to use the probability formula to calculate what the probability is, or the odds formula if you're finding odds. But in this case, we're finding probability. So step 3 is to use the probability formula. For this race here. So that's favorable over total. So the probability of that event, we'll call it A, is equal to favorable outcomes over total outcomes. So in our case, it's 6 over 3, 3, 6. Which if we reduce that down, 6 can go into 336 here. 1 over 56. That's our probability. Or if we did that as a decimal, that would be 0.017857.142, whatever, if we round it off. Or if we had it as a percent, 1.79% if we round that off. So that's a probability that they're going to finish in the top 3. Okay, and there's 6 different ways that they could do that. So that's a permutation type question. So let's see here what else I've got in here. Well, first let's check time here. Okay, that's about 30 minutes. Okay, I'm just going to pause and dig up another one here. Okay, so I'm going to give you one to try here. So try this one here. Let me move that up because I kind of had it under my head there. Okay, so 1 over 56. Okay, so let's try a similar one with permutations here. Okay, so try this one. I'm not going to give you any practice today because I'm going to save it for tomorrow once I go through all the different types here. So try this one. Okay, let's say that a group of 5 students line up at a water fountain, let's say. Can't spell today at all here. Fountain. There we go. Okay. What is the probability? Oops. What is the probability? Oops. Can't type either. Okay. Here we go. What is the probability that James and Alan will be in the first 2 positions? Okay, so give that a try. Give it a pause there and give it a try. And then we'll work it out. It's a permutation type question or a counting question. If you order matters here, because we're wondering whether they're in the first 2 positions. Okay. Okay, so this is permutation. So we want to select the first 2 positions out of 5 students. So our total number, let's get our total outcomes in the question are going to be 5p2. If we take 5p2 and work that out, so it ends up being 5 factorial over 3 factorial, which basically is 5 times 4, which equals 20. Okay, so that's our total number of outcomes. Now our favorable outcomes. Okay, we have 2 boys in 2 positions, right? 2 boys in the first 2 positions. So we can have 2 there or 1 there, so we have 2 ways, 2 favorable outcomes. Okay, 2 favorable outcomes. Okay, so then third point is to make a probability problem out of it. So the probability of being first in line and second in line, call it probability of F, is 2 favorable outcomes over 20, which is going to give us 1 over 10, which if we write that as a decimal, 0.10 or 10%. I usually keep it in fraction form, but all of these are correct. Okay, and that's the probability question. Okay, let's do one more example, as tomorrow we'll probably finish up. Let's do the repeated permutation example, and then we'll get into combinations tomorrow, combinations and other counting principles tomorrow. Let's do this on the second page. So this is a repeated permutation example. Okay, so let's say we have, if you take the word, let's go. We used what, banana last time? Yeah, let's go banana. Oops, too many A's in there. Too many N's. Sorry. There, there. Banana, and randomly arrange the letters. Draw the letters. what is the probability of spelling banana when you draw it out? Yeah. Spelling banana. As you draw it out. As you draw the tiles, let's say. This is repeated permutation. So there, if you think about it, there's only one favorable outcome here, the word. Okay, you can't have it in any other arrangement. So that's easy to figure out. But the important part is to get the total outcomes first. Okay, and this is the number of ways that you can arrange the word banana. Okay, but we have repeated elements. So we have a number of ways we can arrange banana. Okay, so that's repeated permutation. So there's 6 letters. 1, 2, 3, 4, 5, 6. But the A is repeated 3 times. And the N is repeated twice. So this will give us our total number of outcomes for arrangements, total arrangements. So this would be 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. Okay, so if we go take out the 3, 2, 1 here, and then take out 2 there, this gives us 60 over 1, which equals 60 ways. Okay, now how many arrangements of spelling the word banana? Well, our favorable equals 1 way. There's only 1 way to spell banana in the English language. Okay, even though there's repeated letters and stuff, you still have to have it in that order. So this would mean your probability then of spelling the word banana is 1 over 60. Or if we do the decimal on it, 0.0166 or 1.67%. Okay. So that would be an example of repeated permutation type work. Okay, so next day we're going to get into combination and then do some practice from section 5.3. Let's see, what do we got for time here? Okay, that's pretty close to 40 minutes. So maybe what we'll do is, because we're going to do the practice tomorrow, I'll stop here at this point, and tomorrow I will finish up the combination ones, and then we will look at the practice as well tomorrow. Okay, so we'll see you tomorrow.